Hello everyone, this is the lecture series of Operation Research subject and the course code of this subject is ME405. This is unit number 5th and this is the last unit of this lecture series and the lecture number is 35. So today I will discuss about the topic regarding random number. So this is depend on the different types of statistic model used in Operation Research, and for my introduction, myself Rahul Kumar, Assistant Professor of Department of Mechanical Engineering, Suresh Gyan Vihari University, Jaipur. For the case of random numbers, so random numbers are the number that occur in a sequence such that two conditions are met. And first is the value are uniformly distributed over the defined interval or set, and second is here it is the impossible to predict future values based on the past or present ones, and random numbers are important in statistical analysis and probability theories, and this is also used in simulation study for the OR problem using Python language. So the most common set from which random numbers are derived is the set of single digit decimal number. These are the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the single digit number, and the task of generating random digits from this set of not trivial, right? So for this in this topic I will discuss the advantage and disadvantage of the random number, how to use the random numbers in Python programming, and these random number is very important for this operation research. So these are the different types of objectives related to the random numbers. So by the end of this section, you should be able to understand about the random number or the important of the important things of the random numbers, and it is used for the how it is used in probability theories, and the most common set from which random numbers are derived is the set of single digit decimal numbers. These are 0, 1, 2, 3, 4, 5, 6, 7, and 9, and it is used by some statistician, mathematician, and the scientists have long searched for the ideal source of random numbers. So for the case of random numbers, so we have seen some modules or libraries in Python. Some modules and libraries are in Python. These uses the math and the graphics, and the library is a collection of the pre-written code. Library is a collection of the pre-written codes intended to be reused, and Python comes with a couple hundred modules, and there are thousands more third-party modules. And let's look to another built-in module. This is the random, right? So here is a one probability it will occur. This is called the randomness. So the random module provides functions for generating random numbers, and these are the in this case Python random module. So random module is a built-in module to generate the pseudo-random variables, and it can be used to perform some functions or actions randomly, such as to get the random numbers, selecting a random element, selecting the random elements for a list, shuffle elements randomly, etc. So generate the random floats. By this random in bracket, and method returns as a random plot numbers between 0.0 to 1.0 is here. The function does not need any argument. So this type of functions are used in the computers or deterministic level. The same instruction given the same data yields the same results every time, and usually this is what we want. When would we want a program to do different things every time it's run? So these are the games, are the simulations of the real worlds, traffic, weather, galaxies colliding, and the crab photography. So for these kinds of problem we want to random numbers, but we can get real randomness in a deterministic machine, and there are ways hooking up the radiation source and look for the decays, etc., but it is not needed most of the time. So the pseudo random numbers are usually good enough for our purposes, good enough for our purpose. So what does random means? So what is the exact meaning of the random? So an even distribution of result if we are not rolling a die. Just it is these random thing just it is used for the probability analysis. So if we rolling a die, we accept 1 about of 1/6 of the time, and 2 about of 1/6 of the time, and 3 about of 1/6 of the time. So it is used for the uniform distribution. Uniform distribution, and each possibility is in equally likely event. So this is not mean exactly uniform result. So for this case of generating the random number within the range, so it is the random range. It is a method returns the random selected element from a range created by the start or stop and step arguments. The value of start is 0 by default. Similarly, the value of step is 1 by the default case. So an even distribution, it is not enough to be random. So for this case, what if the die always rolled 1 2 3 4 5 6 and 1 2 3 4 5 6 in that order? Random numbers should be unpredictable, and specifically seeing several numbers in the series should not let us guess the next one. Guess the next one. So for this case, the problem is here select the random numbers. So for selecting the random numbers, this is a method of returning the randomly selected element from the non-empty sequence, and empty resources as argument rise and index error, right? So next one is here. And this type of random number used as a pseudo number generators. These are the PRNG, also known as deterministic random bit generator, also known as the deterministic algorithm bit generator, and it is an algorithm for generating a sequence of numbers whose properties approximate the properties of sequence of random numbers. So in slide it is given as a pseudo numbers, and it is approximately uniforms, hard to predict but theoretically not impossible. So all RNGs will repeat eventually. A good one does not for a very long time. So a lot of has research For this purpose, a lot of research has gone into the RNG's model. So RNG means the random number generator. So it is a linear conjugational alternating shift generator and Mesmer twister also. And the art of computer programming spent half of the book on RNGs. And why is much research? Why so much research? It is a cryptograph uses random numbers for season keys like automatically generated on-time passwords. If someone could predict the output of the RNG, they could predict the key and break in. So for this case, the PRNG generated sequence is not truly random because it is completely determined by a initial value and called the PRNG seed, and which may include truly random values. Although sequence that are closer to truly randoms can be generated by using hardware random numbers generator, pseudo random numbers and generators are important in practice for some their speed in numbers generation and their reproducibility, right? So the PRNG number means pseudo number generators are central in applications such as simulators, for example in operation research Monte Carlo simulation, and electronic games, example for procedural generation, and cryptography. And cryptographic application requires that the output not be predictable from the earlier output, and more elaborate algorithms which do not inherit the linearity of simpler pseudo random numbers are needed. So good statistical properties are a central requirement for the output of a PRNG. In general, careful mathematical analysis is required to have any confidence that a PRNG generates numbers that are especially sufficiently close to random to suit the intended use of this. So the von Neumann continued about this misprecision of a PRNG and a truly random numbers, right? So here the randomness involves information. So it gives the different kinds of information, just like here some points are given. These points are randomness involves information of the lack of it, and imagine you are standing at the top of the 50th story of a building. This is the data related to the, suppose you achieve a target of 20,000 profit in your company units. So this is a one type of random variables. If some asked you to predict what the traffic at ground level would be, when will the next cars come around the corner, and why would be in a good position to make the prediction, because you can see the street for a long way. If you are standing at the ground level next to the some building, you have much less information and you could not make a very good prediction about the traffic. And with more information, things are less random. With less information, things seem more random. So that's why the RNG numbers are called pseudo numbers. Means it is not a realistic number, it only give a one random value, right? And with enough information, that is RNG algorithms used and the seed, you could calculate the numbers just like as a customer's computer does, and the number are predictable in that sense. Since we don't usually have that information or want to do that. The number seems random to us. So here are the some qualities for a good RNG, means random number generators. Here are the different qualities for the random number generators and what make a good number generators, just like as a features we mentioned earlier. It provide a uniform distribution. It provide a uniform distribution being unpredictable. So it must be quick to calculate. A typical game would use millions of them, and most of them use integers arithmetic because it's faster than floating point. So for this analysis, it must have a long cycle before it repeats. Every RNG will eventually repeat if run long enough. But if the cycle is a few million numbers, it will seem unpredictable for most humans. For this case, why will it repeat? And imagine you had a perfect RNG which would generate every possible number the computer could represent in no predictable order, that a finite number of numbers. What if you asked for another random numbers after it had done that, and it has to give you the numbers it has already given before, and it has a no other to gives. So these are the random numbers. Suppose in your mobile phone OTP it will come. So this is the one and unique random number for sometimes, right? So some potential issues are regarding these numbers are, so in practice the output from many common PRNGs exhibits artifacts that cause them to fail statistical pattern detection tests, and these include shorter than expected period for some seed states. Such seed state may be called weak in this context, and lack of the uniformity of distribution for large quantities of generated numbers. So correlation of the successive values, poor dimensional distribution of the output sequence, and distances between the where certain values occurs are distributed differently from those the random sequence distribution. So these defects exhibit the fluid PRNGs range from the unnoticeable to very obvious, right? So these are the some random number generation qualities. So using Python random number library, so the for the Python random number libraries, this module implement pseudo random numbers generators for various distribution. For integers, there is a uniform selection from a range. For sequences, there is uniform selection from the random element. A functions to generate a random permutation of the list in place, and a function for random sampling without replacement. So Python random numbers generate is in the random libraries. It can directly import or from random import, and there are the several functions in the libraries, and just you follow this link here and just go to the random number libraries and note the big red warnings. This RNG should not be used for critical application like banking, like this. So the simplest function is random is here. This is equal to chance equal to random bracket. This is the simplest function of this random and gives a random floating point number in the range 0.0, 1, 0. So notation includes 0, 0, not including 1, 0 is here. So usually the probabilities of 1 means will happen, 0 means will not happen. So here the two things is 1 means it will happen and 0 means it will not happen for this case. If random like this and it is less than the 0.7, this is 70% chance to be true. And when if we want to random float in another range, you could be multiply and add this to score of 90 into random plus 10. So this is the range of 10.0 or the 100 in this case. So this is the different cases of these random numbers. So this is the function of the random number. So random number function is used as a just we want to the program to print the output a greeting. So 30% of the time it should be taken by the writing hi only, and 20% of the time should be hello, and 50% of the time it should be how are you. So the random, just like as a program is here, random in function mark means double single bracket hashtag, it gives the a float number between 0 to 1. If RND less than equal to 0.3, then print hi. If else if RND less than equal 0.5, hashtag between 0.3 and 0.5, a space of 0.2, so it print hello, else print how are you. So this is the case of the using random numbers in the organization, and almost the module functions depending on the basic random functions, which generates a random float, so this random module provide a function for generating random numbers. So here is different types of random functions, and this is called the basic function, and this basic function is written as the RANDOM, random, and then two brackets, close bracket, and which generated random float uniformly in the semi-open range, just like it is 0, 0, 1, 0. But Python uses the Mersenne twister as a code generator. It produces 53-bit precision floats and has a period of 2 into 19937-1, the underlying implementation in C also. So all languages, Python or MATLAB or the any other types of programming like Java, Java Servlet, or different types of language like .NET, all are the comes from the C language also. So first you know the very well about the C language, then you move to the another thing is here. So the Mersenne twister is one of the most extensively tested random number generator in existence. However, being completely deterministic, it is not suitable for all purposes and is completely unsuitable for the cryptographic purposes, and sometimes it may be generate some images and sometimes generate some numbers, right? So these are the different types of program written by the numbers here. Suppose this is a one program here. First you collect this program. Suppose you put suppose you give random 30% of the time it should be high, right? Is high. If you take 30% time, then you write high, and then 20% of time you should say, then you take hello, and then 50% of time it should be this is a how are you. So the random number gives the programming is like this. If RND less than equal to 0.3, then is print only high. Otherwise else if. This is the else if statement. This jump the statement in the another way, and in this case this is a limit of 50%, so 0.5, and this is the in between 0.3 to 0.5, a space of 0.2, then it will print a hello in the output. Otherwise else print how are you, right? So this is a one simple program written by the random numbers. So next thing is here random generators. How to create the random generators, and this will given in this slide. So we could multiply at the type of cast to generate cast to get the random integers from the random functions, but these function in the library to do it for us. So some functions are in library just in the programming language, just like rand range. This is a one function, and if you write here rand in bracket stop, so it will stop the process, and between 0 and stop exclusive, not including stop, right? And rand range start and stop, which shows the start and stop process. Between start inclusive and stop is exclusive process. These are the similar as the binary number. 1 shows the yes and 0 shows the no also. In this case start shows the inclusive process and stop shows the exclusive process. So rand range, it gives the start, stop and step likewise, but only gives start plus a multiple of steps also. So the class of random can also be subclassed if you want to use the different basic generators of your own diversing. And in the case of override the random function send and gets state and sets state. These are the two methods. Optionally, a new generators are supplied to gets orbits method. This allows rand range to produce selection of over a arbitrary large range. So the random modules also provide the system random class, which uses the system function os.unrandom function to generate random numbers from sources provided by the operating system. So these are the different kinds of random numbers. And then go to the random integers. So for the random integers, give me a random multiple of 10 between 0 and 100 inclusive. So score is equal to rand range 0, 101 and 10. And what if we had written 100 instead of 100 instead of the 100 is not included in the possible result. So for the integer there is a uniform selection from a range. Suppose in numbers 1 to 10, 1 to 9, so select only 4 to 6 number. 4 to 6 number 4, 5, 6. You want to select here 4, 5, 6, and this will done only by the automatic operation by the software. So for this case, for sequence, there is a uniform selection of random element, a function to generate a random permutation of the list in place, and a function for random sampling without replacement, right? So random integers, just give a also random integers like a comma b. So inclusive on both ends, the same of the rand range, just you can written like rand range in bracket a comma b plus 1. So it always had two arguments, no more or no less. So it returns the number in a range starting at a up to and including b also, right? So here are the different choices for the random numbers. For the case of the random choices, so the Python gives the different types of platform. Can also choose randomly from the list of the alternative. Just you write here sacrifice. This is a one function equal to choice, just like time, money, and the quality. Time, money, and the quality. For this purpose, you must give a list of choice in square brackets. So don't forget the bracket, just like a choice, time, money, and the quality. For this case, type error here choice 2 and takes 2 positional argument, but 4 were given. So it can give a string as an argument instead. So it is a answer equal to choice. This is a ABCD and returns a random letters from the string and could get the same numbers with answers. This is the ABCD rand range 4 for this case. And seeding the RNG. This is the one method. So this is a seeding of the RNG. For the seeding of this RNG, just like as a sometimes it is useful to able to repeat the program exactly with the same sequence of the random numbers. And why this is case? This is a procedure. This is a procedurable simulation. So the cryptography client and the server might need the same numbers, and testing programs and games also, and we can specify the seed for RNG. So seed 42 do it once at beginning of the program, and now the sequence of the numbers will be the same each time the program runs. So seed 43 gives the completely different random number sequence and not necessarily large numbers. Size of the seed does not correlate with size of the numbers. And what if you never set a seed? So Python picks one for you based on the system time, and on some 0 second it can be used as OS randomness instead. So only set the seed once per program. So these are the different types of seeding the RNG process. And expect from this I can give you some definitions about the random number generators. So random number generators, these are the short form is RNG, and this is used to introduce randomness in Monte Carlo simulation. Used in randomness for the Monte Carlo simulations, a RNG is an algorithms that generates a stream of pseudo random numbers, and depending on the same parameter and a initial seed, initial seed. So each stream looks random but can be exactly reproduced from the initial seed. But basic RNGs typically reproduce uniformly distributed sequences, and other distributions are often obtained by their transformation. So for this purpose, sometimes the digits in the decimal expression of irrational numbers are used in the attempt to obtain the random numbers. Most whole numbers are irrational square roots. So entering a string of 6 or 8 digits into a calculator and then hitting the square root button can provide a sequence of the digits that seems random. And other algorithms have been diverse that supposedly generate random numbers. So for this case, linear conjugational generators. So these generators algorithms has the form of, here is small x suffix I is equal to axi plus c. This is the modulus of m. But where I is varies from I 1, 2, 3 and so on, where the initial value x0 called the seed element or initial seed, and must be chosen with care provided a part of the RNG, and the n or modular m operation returns the remainder n and m also, n by m, and the resulting pseudo number integers sequence just like the xn, and it is a 0, 1, 1, 4, and in the range of 0, 1 like as a m minus 1. So convert this sequence to a standard RNG sequence in the range of 0, 1 and uses the transformation just like as a ui equal to xi divided by m is here. So for this case, just move to the example of this. Example of this linear conjugational RNG, random number generator. For the step I, here 0, 1, 2 and 10 numbers are given, and xi is here 3, 6, 5 different types of number. So it will give say ui like this 3 by 8, 0.375, and just like as a different types of numbers. So the random number generation by a linear conjugational RNG with a equal to 5, c equal to 7, m equal to 8 and x0 equal to 3 for this case. And then the inverse transform method, it is used for every CDF functions. Fx equal to x is not decreasing, so the inverse CDF f inverse xu is always well defined. So applying the distribution function fx to the underlying variate x, resulting in variate fxx is equal to uniform 0, 1, uniform between 0, 1. And for this case, it applies the inverse transform method, use a minus c in the two-step algorithm. So for this purpose, it can used by the two types. First, used to favorite RNG to generate the realization u from the variate u and u information if, and compute the x as a realization of x also, right? So this is the different types of graph which shows the inverse transformation method continuous, right? A generation of uniform variates. For this purpose, suppose we wish to generate a realization x from the uniform distribution unit UNF. This is a one type of function, and its value is g belongs from 2 to 10. For the realization u equal to 0.65 and the underlying RNG. Recall that the uniform CDF can be written as u equal to x minus a divided by b minus a, where u is given and x is unknown. Solving the above of for x to obtain the inverse CDF readily yields the formula. So this, and substituting a equal to 2 and b equal to 10 and u equal to 0.65 into and above. So result in the requisite value x equal to 10 minus 2. This is 0.65 plus 2 is equal to 7.2 is here, right? So the generation of the exponential variants. So these are the, suppose we wish to generate a realization x from an exponential distribution, just like the expo 0.5 of rate of L equal to 0. Mean is here. So these are the different kinds of formulas. So we will move to the next thing of this lecture. This is the MCQ question of this series. So in this first problem, this is first, what the pseudo random number generators. So here 4 option is given. First one is an algorithm that generates random numbers with help of the mathematical formulas, and an algorithm that generates random numbers according to user activity, an algorithm that generates random numbers according to the time, and algorithms that generate random numbers with help of user input. So these are the different types of option. So correct answer is here. A is the correct answer. And then move to the next is here. So what should be the return type of rand function is used here? So here the 4 option is given. INT, float, long, double. So the correct answer is here. INT is the correct answer, right? Question number 3. What is purpose of using function srand? So this is to a set of seed of random function to generate the random numbers, to enable the rand function, to improve the efficiency of rand. So it is a correct answer is here, to set a seed of rand function exactly. So for this case, just we move to the next question. This is the fourth question. For this fourth question, what is the range of rand functions? This is the 0 to rand max, 0 to infinity, 0 to like this, and 0 to this. So the correct answer of this question is here. 5A option is right answer for this question. And then move to the question number 6. What is the correct formula for generating random numbers in the range lower, upper, and using RND? So the correct answer is here. D option is correct. So 4 option is given. Rand function percentage upper minus lower, rand function plus lower, rand function divided by upper minus lower plus lower. So rand function divided by upper minus lower plus 1 plus lower. So D is the right answer for this question. Then move to the question number 7. Which of the following will generate random numbers in the range of 1 to 100, both inclusive? So this is the correct answer is D is the correct answer for this question. And then move to the question number 7. What is default value of CD function rand is called the before srand? So this is the correct answer. This is B is the correct answer for this question. And then move to the question number 8. Which header file contains the function rand in C language? So the function rand contain the header file is std library, right? So A option is right. And then C, ninth option, predict the output of the following code. A is compilation error, B is the random number, between 0 and rand max and cannot be predicted, and 0. For this case, correct answer is here, B is the correct answer, random number between 0 and rand max variable. For this case, printf statement. So this is a C language program. So predict the output of the following code. This is the compilation error, random number between 0 to 50 and random number between 0 to 51 and random number between 0 to 49. For this answer, D option is right for this case. And then move to the next. References of this question is here. So these are the different kind of references for this chapter. And if you want more information related to this, then you go through these references. And thank you all of you for this kindly listening this lecture, and thank you.